Welcome to 10th class maths. Let's learn in this video about the probability from the Telangana 10th class lesson. Okay, so in this one, there is more of theory and very basic introduction to the probability. So this is very useful if somebody is learning probability for the first time from 8th class to 10th class, anybody. May not be that big for 11th and 12th kids actually. Okay, there is much more in 11th and 12th than the probability. So once you are clear about the terminology here in probability from this lesson, that is good enough. The practice problems are very simple. If you are going to attempt them in the examination, you should get 100%. So what we cover is, as I said, most of it is theory, introduction, probability, theoretical approach, what is mutually exclusive events, just to define it, finding the probability, complementary events and probability, then introduction to the deck of cards and the probability. This is most likely problems in the probability are either colored balls or the deck of cards or tossing a coin. So this is one of the type. Then where do you use probability, and then exercises, some applications of probability, basic applications, and then more exercise. Okay. So these are the things we will see in this. So first, let's go to the introduction. Okay. Yeah, probability. So, in our daily life, so many times we actually use the terms which are related to the probability. We do normally discuss what is the chances of rain today, right? What is the chance of high traffic today? Okay, what is the chances of going to the office without much traffic? So, these kind of things we talk about, these are all related to the probability. Okay, so let's say Kumar and Sudha are playing a game, and what are the chances of one of them winning? Okay, so we say that it's about 50% because two players are playing. Chances of any of them winning is 50%, right? So if you see in such daily conversations, what we mostly we use this probability terminology. Okay, the words like probably, likely, possibly, okay, chance, luck, all these are related to the terminology of the probability. Okay, so these are all related to one event. Either event can be a game, event can be a tossing a coin, event can be a picking a good pen from a box of pens, right? Event can be a possibility of a rain, possibility of a traffic jam. It can be anything. Okay. So first thing is, uh, these are the terminology generally we use in the term, but the term probability has a specific definition. Okay. Instead of telling in a vague English words, okay, that there are high chances of rain today, okay, we have to tell there are 50% chances of raining, or 70% chances of rain, or some 20% chances of rain. So this is where we are basically converting the probability vague terms into a numerical measurement. Correct? We are attaching a number to the vague sentences which we generally talk. Okay, so this numbering or numerical measure of the events or qualification is called probability. Okay, this is what is probability. Okay, we have to mathematically measure the event and tell what are the realistic chances of that event to happen. Okay, so let's see one example. Consider an experiment. A normal coin is tossed 1,000 times. Heads turned up 455 times and tailed turns up 545 times. So if we try to find likelihood of getting heads, we may say that it is obviously 455 out of 1,000 times because that many times it came before. So your chances are around 0.4%, zero point 0.4 chances. 0.455 are the chances of getting a heads up. Okay. This estimation of probability is based on the result of an actual experiment, right? This is a actual experiment. It is not that some theoretical measurement, correct? So these estimates are called experimental or empirical probabilities. The terminology to is probability is always attaching a number to the occurrence of a event, correct? So why don't you call it probability? Because there are two types. Some probabilities are derived based on the actual experiment. Okay. Some probabilities are based on the theoretical observations or calculations. Okay, they are called theoretical probability. These are all experimental or empirical probabilities. So this is a term which we should understand. Okay, what is the experimental or empirical probabilities? Okay. Um, so as I said, all experimental probabilities are based on the actual experiments and the results uh, of that experiment. Okay. So these are only estimations. Okay. We perform the same experiment for, let's say, another 1,000 times, we may get slightly different data. It may not be same. Okay. Even though you have 0.455% chance of getting heads. Okay. Maybe next 10 rounds we may not get heads. Okay. So there will be slightly different data, but more or less it will be close to that. Okay. So many persons from different parts of the world have done this kind of experiment and recorded the number of heads that has turned up. Example, in 18th century, French naturalist uh, Comte de Buffon, he tossed a coin 4040 times and got 2048 times head. This experimental probability of getting head in his case is this number, right? It's around 0.507. Okay. And same thing is done by another person, Kerrich from Britain. Okay, he recorded 5067 heads in 10,000 tosses of a coin. So this is also around 0.5067 probability. Okay, so many others have done. Okay, and the probability was coming around 5.500. Okay, so as you increase your number of experiments, basically, the results are very close to the natural value of theoretical value. Okay, so these experimental probabilities of getting heads, basically, if you try 10 lakh times or 1 crore times, we may get more close to zero point 0.5 or 1 by 2. Okay, this is the exactly theoretical probability equal to the theoretical probability what you calculate. Okay, then what is the problem of why don't you then just do every probability? Why don't you do more realistic experiments and then derive the probabilities? What's the problem? Okay, so the problem is why do you need a theoretical approach then? Every event you actually do the realistic experiment and then add it to the probability, right? The problem is not all the experiments are so easy. Okay, some of them were very, very expensive. Okay. Okay. So that is where we get the problem, and we require a theoretical approach also along with the realistic empirical probability. Okay. So in theoretical approach, we assume few things basically. We consider situations. We can consider that the event is always fair. In this case, tossing a coin, the coin is a fair coin means it when you toss it, the heads or tails are equal chances basically. That there is no difference in the weight, so that always you get more chances of getting heads or tails, those kind of things. Okay, so it's a fair coin, and then it is symmetrical. Okay, so these kind of things we assume. So that means they are basically unbiased events. Unbiased means they don't depend on any external factor or event. Okay. Uh, So we assume all these things, and outcome in an experiment is equally likely. Equally likely means getting a heads is chances of getting heads is equal to chances of getting tails. Okay. So this is what we assume. These are the key terms which we need to understand from probability. What is fair event? What is a unbiased event? Right? All these things are very important because we may have some biased events also. Okay. So before going there, first you understand the probability approach, theoretical approach. We assume these are the things. Okay. And then let's check this one. Outcome of which of the following experiments is equally likely. Okay. The term here we are checking is equally likely. Okay. Remember this. Equally likely is what is equally likely? Means if the event has whatever number of outcomes, all outcomes are equally likely possible. There is no bias to any one of them or some of them. All are equally possible events. Okay. Suppose you take a dice. Okay. Dice has six faces. So one, two, three, four, five, six. What is the getting a digit one, two, three, four, five, six when a dice is rolled? So this is definitely a equally likely event because every side has equal chances unless until the dice is not exactly in cube shape. Okay. It may be some cuboid. Okay. Where high possibility that only the lengthier side numbers will come. Right. Like in olden days in Indian mythology, you see, right? Those are four side dice basically, not six side dice. Okay. So a regular dice in today's world is a equally likely you can get all six possibilities. Okay. Selecting a different color ball from a bag of five red balls, four blue balls, and one black ball. Okay. Uh, is it same? Because there are more red than black ball. Okay. How likely you get a black ball? Right? There is only one black ball. So obviously you will get more red balls. Correct? So this is not equally likely event. Okay. It doesn't mean that we cannot calculate the probability. We can calculate, but we should first understand, is it a equally likely? Picking a ball is equally likely event. Okay. But not picking the same red color ball is not equal to the chances of picking a black ball. Okay. That we need to understand. Winning a game of carom. Um, we can't tell winning or losing is equally likely. It really depends on the capability of the person who's playing, right? So that way we cannot say equally likely. Not every person has equally likely chances. Okay. Units place of two-digit number selected may be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. So what is the probability? Yeah, definitely units digit as any of these numbers, right? So that is equally likely. Okay. But if I tell only zero, then I will tell, yeah, it is less chances of getting only zero compared to the all other numbers. Selecting a different color ball from a bag of 10 red balls, 10 blue balls, and 10 black balls. This is definitely a equally likely because every pack of colors, every colored balls has equal chances, right? And then raining on a particular day in July, um, this we cannot tell. This is basically our weather report. Most of it is comes from the historical data. Okay. So from the historical data we tell, and we normally never see a 50% or something. Either it is highly possible rain or not possible, right? So definitely it is not equally likely raining and not raining. Okay. Not every outcome in every experiment is equally likely. Yes, definitely not. All are not equally likely. Okay, give some examples. You can think of some examples. Okay. Then another activity you can do is you can try yourself how you are getting a tossing a coin, heads, number of heads, and the probability of heads, number of tails, and probability of tails. You can see yourself, are you converging to 50%? Because when you are tossing a coin, you have two outcomes. Either you get a head or you get a tail. Definitely, coin cannot stand, and we rule out basically that coin can stand on the edge, right? So there are only two events. So theoretically, heads or tails has chances of getting 50% chance of getting heads or tails. Now your real experiment also should merge to the same values. Okay. Now, so from this, all this we understand probability of an event P of E, it is defined as number of trials in which the event has happened by total number of trials. Okay. Number of trials in which the event has happened and total number of trials. This is what we are trying to put the numbers here. Okay. So this is one way of calculating the probability. Okay. The assumption of equally likely outcomes. Of course, this holds for the tossing of the coin. Okay. Then probability and modeling. Uh, yeah, why we need modeling for the probability? As I said, we can actually do the experiment and calculate. So definitely, the problem is some of the experiments are very costly that we cannot repeatedly do that. Tossing a coin, throwing a dice is very easy, but launching a satellite, uh, all these things are a phenomena of earthquake, chances of rain. We cannot control all these things, right? So definitely, you need a theoretical way of calculating probability. That is where the theoretical probability comes into picture. Okay. So in this case, this is the previous equation you learned is from the actual experiment, right? Probability defined from the empirical data. Okay. And this is the theoretical data. Number of outcomes favorable to T. Okay, if T is a event, how many number of favorable events are there, and number of all possible outcomes of the experiment. In case of tossing a coin, you have two possibilities total. So denominator is 2. And if I say what is the possibility of getting a heads, you have only one option. Number of outcomes is only one, right? Only heads is possible. So 1 by 2. In case of dice, if I say possibility of getting a odd number, then you will count total number of possibilities are 6, 1, 2, 3, 4, 5, 6, and possible favorable outcomes are 1, 3, and 5, which are 3. So 3 by 6, which is equal to 1 by 2. That is how you calculate the theoretical probability. Okay. The definition of probability was given by Pierre Simon Laplace in 1795 officially. Even though we could have used many ways in many countries in different ways, but this is where it is actually theoretically put on a paper and real definitions of the probability. Okay, and we need to understand next mutually exclusive event. Okay, the term itself tells something. The events are mutually exclusive. Okay, which means if a coin is tossed, we get head or tail. Okay, but not both. Correct. So if you get heads, only heads is possible. Now in that experiment, there is no possibility of again tails. Correct? If you get a tails, only tails is possible, not heads. So both either you get a heads or a tail. They're mutually exclusive. And this is what is uh, mutual exclusivity of the events. Okay. Occurrence of events prevents the occurrence of other events. Correct? If one is possible, then others are not possible. Okay, such events are called mutually exclusive events. This is the important terminology to understand. You may get some probability questions later in your future chapters, future classes, where mutually exclusive events are not possible. Maybe other things also possible. Yeah. So remember this. Okay. Now, how to find probability? How do we find probability of events? First thing is we need a sample space. Okay. Set of sample space is nothing but set of outcomes. What are the possible outcomes and what are the favorable outcomes? Okay. So once you know these two, we know probability is defined as favorable outcomes by all possible outcomes. Okay. So let's do some examples. Find the probability of getting a head when a coin is tossed once. Also find the possibility of getting a tail. Okay. So possibility of head is number of outcomes of the outcomes favorable to the event, which is one. Only heads, right? Out of the two, only heads I'm interested in. What is the total number of possible outcomes? 1 by 2, right? So P of heads is probability of heads is 1 by 2. Similarly, probability of tails also 1 by 2. Okay. A bag contains a red ball, blue ball, and a yellow ball. All the balls being of the same size. Manasa takes out a ball from the bag without looking into it. What is the probability that she takes a yellow ball or red ball or blue ball? Okay, in this case also, what are the total possible outcomes? Number of possible outcomes is 3. Okay, and favorable outcome in each case is 1. Okay, either probability of yellow, probability of red, probability of blue. All the cases I have 1 by 3, 1 by 3, and 1 by 3. This is the possibility. Okay. So if a event, okay, possibility of heads and possibility of tails, both if you add up, you will get one. And the possibility of yellow drawing a yellow ball, red ball, or blue ball, if you sum up, you will get one, because these are the three events which you can do, right? And sum of the three is always one. Probability of sum of the three is always sum of all the events is always one. Okay. Okay. In an event like throwing a dice, probability of getting less than three and getting a three or more than three are not elementary events of the possible outcome. In tossing two coins, these are the elementary events, right? Either you get, when you toss two coins, you get either heads and heads, heads and tails, tails and heads, or tails and tails. These are the four events you'll get. Okay. So you can clearly see, if tossing a coin, single coin, is two possible outcomes are there. Tossing a coin twice, you will get 2 into 2, which is 4. Okay. Suppose the dice is thrown once, what is the probability of getting a number greater than 4? Okay, so sample space is 1, 2, 3, 4, 5, 6, which is 6 outcomes are possible. Okay, out of that, I need to check the events, favorable events are more than 4, that is 5 and 6. My favorable event set contains only 5 and 6, that is number of favorable events are 2. So probability of getting more than 4 is 2 out of 6, which is 1 by 3. Okay. If f is other one is defined as getting number less than or equal to 4, then my sample set is same outcome. Sample space is same. Favorable outcomes are 1, 2, 3, 4, because my success is basically getting a number less than or equal to 4, right? So probability of event is 4 by 6, which is 2 by 3. And if you sum up these two, 1 by 3 plus 2 by 3, okay, it is equal to 1, because getting a 1, not getting a 1, not getting a getting a number and not getting that number, both are mutually exclusive events, right? So if you add them, you will get which are complementary basically. So if you add them, you will get definitely 1, probability 1. Okay. So these are basically complementary events. Okay. That's what just I was trying to tell. Complementary events of possibilities. So getting a heads and getting a tails are in the previous case 1 by 3 plus 2 by 3. All these are basically complementary events. Okay. Either you get a number which is more than 4 or less than or equal to 4, right? So if you sum up, that concludes complete event, that is 1. Okay. So normally complementary event you represent by either E dash like this or E dash like this. Okay. P of E and P of not E, which is equal to 1. Correct. So this is another important thing to remember. Okay. In getting heads is complementary to getting a tail? Definitely, because there are only two events. Okay. If you are not getting tail, you will get head. Correct. If you are not getting heads, you will get tails. So they are complementary to each other. In case of dice, is getting one complementary to events of getting two, three, four, five, six? Yeah, definitely. Either you get one or you get anything other than one. Other than one possibilities are two, three, four, five, six. They are definitely complementary. Okay. And there is another small definition of impossible and certain events. Okay. Okay. Very simple example. What is the possibility of getting a 7 when you throw a dice? There is no 7, right? So definitely probability of getting a 7 is 0 out of 6, which is absolutely 0, not possible at all, right? So this is a impossible event. Impossible event, and very certain events are always happens. Okay. So possibility of getting a 7 in throwing a dice is always impossible event. So this is what the definition of impossible event. The probability of an event which is impossible to occur is 0. Such an event is called impossible event. Exactly opposite to that is sure or certain event. Possibility of getting 1 to 6 on throwing a dice. Definitely you will get one of it. right? So obviously the probability of getting 1 to 6 in when you throw a dice is always 1, 6 out of 6 possibility, right? So this is called sure or certain event. Okay, so note down this terminology. As I said in the beginning, this chapter of probability is very, very basic definitions of probability. Learn carefully. This is very useful for your coming 11th class and 12th class and all competitive exams, and later when you are going into job market. Okay, most of the tests have probability questions, so you should understand the basics of probability for sure. Okay, from the definition of probability we see that the numerator is always less than or equal to denominator, obviously, because probability of uncertain event or impossible event is 0. Probability of certain event is 1. So remaining any other probability should be in between that value. So probability of an event is normally lies between 0 less than or equal to 0 to 1 exclusive, basically, right? In between 0 to 1 exclusive, inclusive. Okay. A child has a dice whose X faces shows the letter A, B, C, D, E, F. The dice is thrown once. What is the probability of getting A or D? Of course, A only one is there. So you will get 1 out of 6. D is again 1, 1 out of 6. What is the, which of the following cannot be probability of an event? Okay. 2.3 is not possible because probability should lie between 0 and 1. So this is not possible. Probability cannot be negative. This is also not possible. 15% is around 0.15. So this is possible. Zero point 0.7 is possible between 0 and 1. Okay. Let's learn the deck of cards and probability of it. Okay, this is one of the most common problems which will come is from deck of cards. Either it is in 10th class or in your later stages of education. Okay, so understand this very well. If you are already playing cards, then you know it already. Okay, otherwise, okay. A deck of cards consists of four suits. Okay, you can see, right? Four different suits. Okay. Okay, each suit has a special symbol. This is called flowers. Okay, or this is called uh, black clubs. It's called here. Okay, black clubs. Okay, this is also called flowers. Okay, this is called spades. Okay, this is called spades. You can see here, right? Black spades. Okay, because it is black in color, it's called black spades. Okay, and you have red heart. Correct. This is heart symbol, red heart, and this is red diamonds. Okay, red diamond. So you have four suits. Okay, and there are two black color suits, two red color suits. Correct. Okay, this is clubs, spades, hearts, and diamond. You have two red color, two black color. Each suit has 13 cards. Okay, if you consider A as one. Okay, A, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and J, Q, K. Okay, jacks, queens, and kings. Jacks, queens, and kings. Okay, so you have to total 13 cards in one suit. So 13 into 4, which is 52 total cards in one deck. Total cards in a deck are 52. Each suit has 13 cards. Okay, and then if they ask you black color cards, there are 2 into 13, that is 26. Red color cards, 26. And other things you should know is number card. Okay, which is number card here? 2, 3, 4, 5, 6, 7, 8, 9, 10. These are the number cards. Okay, alphabet cards A, J, Q, K. 4. 4 in one suit basically. So 4 into 4, that is 16 in a deck. Okay, and if they ask you face card, there are three cards which has face on them, right? Jacks, queens, and kings have face on them, right? So 3 in a suit and 3 into 4, that is 12 in a deck. Okay. Now, once you know all these things, there are so many different varieties of questions which you can solve from this deck of cards. Okay. One card is drawn from well shuffled deck of cards. Calculate the probability of the card will be a ace or not a ace, not an ace. Okay. There are four aces A, right? Ace is A. Okay. There are four aces, right, in the deck of cards. So 4 by 52. 4 by 52, which is nothing but 1 by 13. This is the probability of getting a ace. How many are not ace basically? So this is exactly the complementary event of the previous one, right? So that is either you can directly say 12 by 13 or uh, 48 by 52. Okay, you can say 12 by 13 or you do it this way. 52 cards minus 4, these are the non-ace. Correct? That is 48. So 48 by 52, which is 12 by 13, or 1 minus 1 by 13, which is 12 by 13 anyway. So if you sum up these two, basically you will get 1, because either card will be ace card or non-ace. These are two mutually exclusive events. Correct? Okay. You have a single deck of well shuffled cards. Then what is the probability of card drawn will be a queen? Okay. How many queens there in a deck of cards? Four. Correct? One of each suit. So 4 by 52, which is 1 by 13. Okay. What is the probability of that? It is a face card. Okay. There are three face cards in a suit. So 3 into 4, 12. 12 by 52 or 3 by 13. Okay. What is the probability that it's a spade? There are 13 spades in a deck of cards. Correct. This is one suit. Spade is a suit. So 13 by 52, which is 1 by 4. Okay. What is the probability that the face card of spade? Okay. Face card of spade, you have only three. Three spade face cards. Correct. So 3 by 52. Okay. Uh, that's the probability. And what is the probability that it's not a face card? Okay. So it's not a face card. You have 40, right? A to 10. That is 10. 10 into 4, 40. 40 by 52. You can simplify it further. It will be like 10 by 13. Okay. So these are the kind of problems which you see in the deck of cards problems. Okay. Then use of probability. Let us look at some more occasions where probability may be useful. Okay. We'll go through these examples, we'll understand it very well. Sangeeta and Reshma play a tennis match. It is known that the probability of Sangeeta winning the match is 0.62. What is the probability that Reshma winning the match? Okay. In a tennis match, you don't have a draw, right? Either a person will win or a lose. Okay. If Sangeeta's winning chances are 0.62, Reshma winning is exactly complementary to the previous one. Correct? It's exactly complementary. So if P of S is 0.62, P of R is 1 minus P of S, okay, which is 0.38, because R and S are complementary. Sharada and Hamida are friends. What is the probability that both will have different birthdays or same birthday? Okay, ignore the leap year. Okay, so how many days in a year? A non-leap year? 365, correct? So you have 365 total outcomes possible, and out of that, Hamida's birthday, let's say one of the day. Okay, let's say it is one of the day is Hamida's birthday. Okay, now uh, Sarada's birthday will be falling on same day. What is the probability? Only one out of 365. Only one out of 365 chances, right? But both have same different birthdays. Okay, different birthdays. You remove that one day, so you will get 364 other days where a second person birthday can be, right? So in that case, probability of Hamida's birthday is different from Sharada's birthday is 364 by 365. Correct? 364 by 365. Very, very high chances. 99 point, close to 99.9 percentage. Right? And probability of Sharada and Hamida have same birthday is 1 minus P, which is 1 by 365. Okay, very less probability. Okay, so this is how you will use the complementary nature of the events. Okay, another question. There are 40 students in a class 10th of school, of whom 25 are girls, 15 are boys. The class teacher has to select one student as a class representative. She writes the name of the student on a separate cards, the cards being identical, and puts them in a box and shuffles them thoroughly. She then draws the card from the box. Compute the probability that the name written on the card is a girl or a boy. Okay. So out of 40, if you pick one of the person, what is the probability that she's a girl? Okay, the person is a girl. Total is obviously we know 40. Okay, outcome total possible outcomes are 40. Favorable outcomes for girl are 25 because there are 25 girls. So probability of girl getting selected is P of girl is 25 by 40, which is 5 by 8. Okay, and the probability of boys, yeah, for number of possibilities are 15 because there are 15 boys. So 15 by 40, which is 3 by 8. And these two are complementary to each other because selected person is either boy or a girl. Correct? They are mutually exclusive and complementary. So if you sum them, you will get 1. 5 by 8 plus 3 by 8, you will get 1. Okay. So these are the kind of examples and problems which will come in probability at the entry level. As every time I'm repeating, probability is very, very exhaustive and huge as you go into the next classes. So better learn all the basics now and no mistake. Okay. So let's do this exercise part. Okay. Complete the following statements. Probability of an event E, probability of event not E, right? Some of them is 1. We know this is the complementary nature of the events. Okay. Probability of event that cannot happen is 0. We call it, what we call it? Uh, Impossible event. Correct? The probability of event that is certain to happen is 1. Okay. And we call it sure event or certain event. Okay. The sum of probabilities of all the elementary events of an experiment is 1 because always sum of probabilities is 1 because at least one of the event will happen. One of the elementary events will happen. Okay. The probability of an event is greater than or equal to 0 and less than or equal to 1. Probability always remains between 0 to 1 inclusive. Okay. Next. Following of the which of the following experiments have equally likely outcomes? Explain. Okay. A driver attempts to start a car. The car starts and does not start. Okay. It is not exactly equally likely, depends on many factors. Okay. So we cannot say anything about it. Okay. So it is not equally likely out. A player attempts to shoot a basketball. Okay. She or he shoots or misses the shot. Okay. This is also not equally likely. It depends on the ability of the player. We cannot say both players are of same ability. A trial is made to answer a true or false question. Okay. So you have only option is to say either true or false. Okay. So either the question you will say true or you will say false. So in this question, we know obviously the outcome is equally likely. Okay. The answer is right or wrong. Okay. So this has equally likely outcomes. A baby is born, it's a boy or girl. So there are only two options, either it's a boy or girl. So obviously it's a equally likely outcome. Okay. Next. Uh, if probability of event is 0.005, what is the probability of not E? Okay, we know this is complementary event. Okay. So probability of the complementary event is 1 minus the probability of the event, which is 0.95. Okay, next. A bag contains a lemon flavored candies only lemon flavored. Malini takes out one candy without looking into the bag. What is the probability that she takes out orange flavored candy? First question. There is no orange flavored candy in that bag. Only lemon flavored are there. So obviously this is a impossible event. So probability is 0. What is the probability of getting a lemon flavored candy? This is a certain event because there are only lemon flavored candies in that. So you will get probability of 1. Okay, next. Rahim removes all hearts from the cards. Okay, what is the probability of getting an ace from remaining deck? Okay, so remaining deck has how many cards? Okay, 52 minus 13, which is 39 cards. Okay, and number of aces are 3 in that. So probability of getting ace is 3 by 39, which is 1 by 13. Okay, getting a diamonds. Okay, how many diamonds are 13 diamonds are there? So 13 by 39, which is 1 by 3. Okay, next. Getting a card that is not hot. Okay, all hearts are removed, so this is a certain event. Now you will get a card which is not hot. Okay, so which means it's a certain event and the probability of event is 1. Getting a ace of heart. This is an impossible event because there are no hot cards actually. Okay, so probability is 0. Next, it is given that a group of three students, in a group of three students, the probability of two students not having the same birthday is 0.992. What is the probability that two students have the same birthday? Okay, so this is simple. This is just a complementary event. If it is given that two students having the same birthday is 0.992, not having same birthday, so obviously the probability of having same birthday on the same day will be complementary. So 1 minus this, which is 0.008. A dice is rolled. Find the probability of getting a prime number, a number lying between 2 and 6, and an odd number. Okay? So when you do, roll a dice, basically, how many total outcomes? 6, 1, 2, 3, 4, 5, 6. Prime numbers in that are 2, 3, 5. So probability of getting a uh, prime number is 3 by 6, which is 1 by 2. Number lying between 2 and 6 are 3, 4, 5. Okay, so again, probability is 1 by 2. And odd number, you have 1, 3, 5. These three are odd numbers. So probability of getting odd number is again 1 by 2. Same. Next. I think we are just repeating it. Okay. What is the probability of selecting a red king from a deck of cards? Red king. Okay. There are two red kings in a deck of cards, correct? Which is diamonds and hearts. Okay. Is diamonds and hearts. So 2 by 52, which is 1 by 26. Okay. So let's learn the more applications of probability now. Yeah, let's do some more applications of probability. We will learn it through some example problems. What kind of problems can come? Okay, a box contains a three blue, two white, and four red marbles. Okay, so if you see here, all the colors are not equally probably uh, possible, right? There is more chances of red than blue and then white. Okay. If a marble is selected at a random from the box, what is the probability that it will be a white? Okay. So first thing is, what is the probability of picking a marble is any of these colors is 3 plus 2 plus 4. That is 9, right? All possible outcomes are 9. There are only 9 marbles, so you will pick one of them, right? So total outcomes are 9. And then how many white are there? 2. So 2 out of them are white. So you have possible favorable events is basically 2, right? So probability of white is 2 by 9 and the probability of blue is 3 by 9 because there are 3 blue balls, that is 1 by 3, and the probability of red is 4 by 9 because there are 4 red marbles. So if you sum all of them, you will get exactly 1 because you will pick one of the ball anyway, right? Yeah. Harpreet tosses two different coins simultaneously. Say one is of 1 rupee, other one is of 2 rupees. Example, both can be same coins also. What is the probability that she gets at least one head? Okay. When you toss two coins, what are the options you get? Either head on both the coins, head tail head, and tail tail. Right? These are the four possible combinations outcomes which are possible when you toss two coins at the same time. Correct? So possible outcomes is four. And what is the question? What is the possibility that she gets at least one head? One head is possible in any of these three combinations. Correct? One head is possible in any of these three combinations, either head head, head tail, and tail head. Correct? So three out of four is the answer. Okay. Now, till now we were doing only the type of events which we are generating where the possibilities are finite. Okay, what if there are uncountable possibilities? Can we derive a probability of those events? Okay, let's do it with some example. Okay, in a musical chair game, the person playing the music has been advised to stop playing the music at any time within 2 minutes after she starts playing. Okay. What is the probability that the music will stop within the first half minute after starting? Okay, which means you have 2 minutes of time. Okay, within which music can stop at any point. Okay, what is the probability of first half minute? Okay, so we really cannot measure from number of seconds, number of milliseconds or microseconds. We can't really measure that way. Only thing you can measure is on a graph. Okay, how much is first half minute compared to the 2 minutes, right? So total event is, let's say, 2 minutes is this is the line, okay, 2 units. Then half minute, okay, half minute is half the unit, correct? So total distance in which outcome can lie is 2 units. Distance favorable to the event is half unit, correct? So half by 2, which is 1 by 4. This is the probability. So if you see here, this question is different from the other questions, which is we cannot really count the number of favorable outcomes or so. Okay, we will measure in this way. Okay, now other one. A missing helicopter is reported to have crashed somewhere in the rectangular region as shown in the figure. Okay, uh, the figure is something like this: 6 kilometers of forest is there, 6 kilometers by length and 4.5 kilometers by width, and there is a lake in the corner which is of you can calculate, you can measure, right? 2.5 width and 9 minus 6, which is 3 kilometers length. Okay, 3 by 2.5. This is the lake area. Okay. The question is, what is the probability that it crashed inside the lake shown in the figure? Okay. So this is also you cannot really exactly measure based on number of outcomes and other things. Okay. So go by the area of the lake and total area. Okay. So the total area is 9 into 4.5. Correct? 40.5 kilometers square. 9 into 4.5 length into breadth. Area of the lake is 2.5 into 3, which is 7.5 kilometers square. So the probability of helicopter crashed in the lake is 7.5 by 40.5, which is 5 by 27. Okay. So this is a way of solving such problems where exactly number of outcomes are not clear. Okay. A carton consists of 100 shirts, of which 88 are good, 8 are minor defects, and 4 have major defects. Okay. Johnny, a trader, will only accept the shirt which are good, but Sujata, another trader, will only reject the shirts which have major defects. Okay. One shirt is selected at random from the carton. What is the probability that it is acceptable by Johnny? It is acceptable by Sujata. Okay. So Johnny accepts what Johnny accepts. He will accept shirts which is good only. Okay, so there are 88 are good out of 100 shirts. So his probability of selecting is 88 by 100. Acceptable is 88 by 100. Whereas for Sujata, she will reject only if it is major defect. So major defect is only 4 are major defect. Okay. So she will reject only 4 out of 100. Rest all are acceptable. That is 88 plus 8, which is 96. 96 by 100 is acceptable by Sujata. So this is how we calculate 0.88 and 0.96. Okay. Yeah. Another question. Two dice, one red and one yellow, are thrown at the same time. write down all the possible outcomes. Okay, these are all the possible outcomes. You will start from 1 comma 1 to 6 comma 6. There will be total 6 on this dice and 6 on this dice. 6 into 6, 36 possible outcomes are there. Okay. What is the probability that sum of the two numbers appearing on the top of the dice is 8, 13 and less than or equal to 12? 8. Okay. To get 8, it should be 6 comma 2. Okay. Then 5 comma 3. Right. We'll just mark it. 6 comma 2, 5 comma 3, 4 comma 4, 3 comma 5 and 2 comma 6. These are the only possible options, outcomes to get when two dice are thrown and sum of the dice is 8. Correct? That is 5. So it is 5 out of 36 are the possible outcomes. Okay? For the getting 8. Okay? Now, what is the possibility of getting 13? Okay, the maximum you can get is 6 plus 6, which is 12. So 13 is an impossible event. So probability of getting 13 is 0. And what is the probability of getting less than or equal to 12? Definitely 6 plus 6 is 12. So everything is maximum is 12. So everything is 2 to 12. So less than or equal to 12 will it's uh, a certain event, correct? So probability is 1. Okay. So this is how you solve these problems. Let's do exercises and then optional exercise. Okay. Let's do the exercise 13.2. Okay, a bag contains three red balls, five black balls. A ball is selected at random from the bag. What is the probability that the selected ball is red and not red? Okay. So clearly looking at it, you can tell this is uh, a complementary event, right? So selecting a red ball is total number of balls in the bag is 8. That's the total number of outcomes. Selecting a red ball is three outcomes are there. So 3 by 8, correct? P of R, probability of selecting a red ball. And the complementary event, which is P of R dash equal to 1 minus PR, which is 1 minus 3 by 8, which is 5 by 8. Okay, next. A box contains 5 red marbles, 8 white marbles, and 4 green marbles. One marble is taken out of the box at random. What is the probability that the marble taken out will be red, white, not green? Okay, so same. Total number of outcomes is 17. 5 plus 8 plus 4. Okay, number of red marbles are 5. So probability of selecting a red marble is 5 out of 17. Probability of selecting a white marble is 8 out of 17. Probability of selecting a non-green ball, okay, is sum of other two basically. Okay, you ignore the green, 5 plus 8, that is 13 by 17. Okay, yeah, next. A kiddie bank contains 100 50 paisa coins, 50 1 rupee coins, 20 2 rupees coins, and 10 5 rupees coins. If equally likely that one of the coin will be fall out of when the bank is turned upside down, when the kiddie bank is turned upside down, what is the probability that the coin will be 15 paisa coin or the 5 rupee and not 5 rupee coin? Okay, so simple. Total number of outcomes is 180 because there are 100 plus 50 plus 20 plus 10. Okay, number of 50 paisa coins are 100. So probability of fallen coin be 50 paisa is around 5 by 9. Okay, and the probability of fallen coin be 5 rupees is 1 by 18. So we want the complementary event of 5 rupees. Oh, sorry, this is not 50 rupees, this is 5 rupees. Probability of fallen coin is not 5 rupees, is P of 5R bar, which is y minus 1 minus P of probability of 5 rupee coin, which is 17 by 18. Next. Gopi buys a fish from a shop for his aquarium. The shopkeeper takes out one fish at random from the tank containing 5 male and 8 female fishes. Okay, what is the probability that the fish taken out be a male fish? Okay, this is a straightforward, simple question. Okay, you have the template ready. It's 5 out of 13. Next. A game of chance consists of spinning an arrow which comes to rest pointing at one of the numbers 1, 2, 3, 4, 5, 6, 7, 8. Okay. And these are equally likely outcomes. Okay. What is the probability that it will point at 8, an odd number or a number greater than 8 or a number less than 9? Okay. This is same as the dice problem. In dice, we have 6 outcomes. Here, there are 8 outcomes. So just do it same way. Total number of possibilities is this set. Okay. Possibility of pointing at 8 is 1 out of 8. Probability of pointing at odd number is if there are 4 odd numbers 1, 3, 5, 7. So 1 out of 2. Probability of pointing at a number greater than 2. There are 3, 4, 5, 6, 7, 8. That is 6. 6 out of 8, which is 3 by 4. Okay. Probability of number less than 9 is a certain event. So it is 8 out of 8. Next. One card is selected from a well shuffled deck of 52 cards. Find the probability of getting a king or a red color, king of red color, a face card, a red face card, a jack card, spade, and queen of diamond. Okay. This is a simple card problem. Total number of possibilities are 52. Number of red cards in the deck are 2. Red kings are 2. So 2 out of 52, which is 1 by 26. Number of face cards are 3 into 4, that is 12. So 12 out of 52, which is 3 by 13. Okay, probability of picking a jack card is jack of hearts basically. Jack of hearts is only 1, so 1 by 52. Okay, probability of picking a spade, there are 13 spades, so 13 by 52, which is 1 by 4. Okay, and probability of picking a queen of diamond, there is only one queen of diamond, so 1 by 52. Next. 5 cards, the 10, jack, queen, king, and the ace of diamond are well shuffled with their face downwards. One card is selected at a random. What is the probability that the card is a queen? Okay, let's do one by one. Same, similar problem. Only thing is total number of outcomes are only 5 here because only 5 cards are there. Okay, probability of queen in 5 cards is 1 by 5. Remaining cards available are 4. So, probability of getting a ace in 4 cards, ace in the 4 cards because that card is not replaced. The first card which is taken out is not replaced. Okay, is 1 by 4. And the probability of queen in the 4 cards is 0 because it's a queen is already taken out. So in the remaining 4 cards there is no queen. So it's an uncertain event or impossible event. Okay, so probability is 0. Next. Well, defective pens are accidentally mixed with 132 good ones. Okay. It's not possible to just look at a pen and tell whether it's good or defective. Okay, one pen is taken out at random from this lot. Determine the probability that the pen taken out is a good one. Okay, this is simple. Total number of outcomes are 132 plus 12, which is 144. And good pen probability of picking a good pen is 132 out of 144. You can simplify it further. A lot of 20 bulbs contain 4 defective ones. Okay, 20 bulbs already have 4 defective ones. One bulb is selected at a random from the lot. What is the probability that the bulb is defective? Okay, first question, let's see. 20 are there, defective are 4. So 4 by 20, this is the probability of picking the defective bulb. Sorry, not pen, is 1 by 5. Okay. Now, second part is suppose the bulb selected is in previous case is not defective and not replaced. Okay. Now, one bulb is selected at a random from the rest. What is the probability that this bulb is not defective? Okay. So, remaining bulbs after taking the good one out is 15 good ones and 4 defective ones, which is 19. Okay. Probability of getting a good bulb now is 15 out of 19. Okay. So, be careful about the questions. Questions will be something like this, very slightly twisted. But sure shot, you can get 100% marks in probability, I'm sure. Okay. Next. Box contains 90 discs which are numbered from 1 to 90. Basically, it's a question of picking 1 to 90, right? A dice game with outcomes 90. Okay. If one disc is selected at a random from the box, Find the probability that it bears a two-digit number, a perfect square number, or a number divisible by 5. Okay, so simple. Number of disks are 90. Total disks with the two-digit numbers are, you have 81. So probability is 81 by 90, which is 9 by 10. Okay. Total number of disks with the perfect squares are 8. Okay, you can see there 4, 9, 16 up to 81. Okay. So probability of picking disk with perfect square is 4 by 45. Okay. Next, total number of disks with a number divisible by 5 are 18. Okay. Probability of picking this one is 1 by 5. Okay. Next. Suppose you drop a die at a random on the rectangular region shown in the figure. What is the probability that it will land inside the circle with diameter 1 meter? Okay. So this is the area problem. You will calculate the probability based on the area uh, there, right? So area of the rectangle is 3 into 2, which is 6 meter square. Area of the circle is pi r square, which is 22 by 7 into half. 1 is the diameter, so half is the radius, half meter, which is 0.785. Okay. So probability of uh, drop falling on the circle is 0.785 by 6, which is around 0.1308. Okay, this is the probability. Next. A lot consists of 144 pens, of which 20 are defective and the other are good. Okay. Shopkeeper draws one pen at random and gives it to Sudha. What is the probability that she will buy it and she will not buy it? Okay. So both are definitely complementary events. So yeah, one is the whatever is the probability, one minus probability is the other one. Okay. So total number of pens are 144. Number of defective pens are 20. Sudha picks a pen at random and check if it is good, she will buy. Otherwise, no. Right. So probability of buying a good pen or pen is 144 minus 20 by 144, which is 31 by 36. Okay. So probability of not buying the pen is 20 by 144 or 1 minus 31 by 36, which is 5 by 36. Okay. Next. Two dice are rolled simultaneously and counts are added. Okay. Complete the table given. Okay. When two dice are thrown, the options are 1 comma 1, right, which is 2, sum is 2, 1 comma 2, 3, like this, right? So possibilities of getting 3 on 2 dice is 1 comma 2 and 2 comma 1, so which is 2 by 36. Okay, possibilities of getting sum of 4 is this one. So similarly, all these things you can map and you can fill the table like this. This is the complete table. Okay, just to confirm that sum of all these things should be 36 back to, right? 1 plus 2 3, 3 plus 3 6, 6 plus 4 10, 10 plus 5 15, 21, 26, 30, 33, 35, 36. Okay, a student argues that there are 11 possible outcomes. Okay, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Correct? It is correct. 11 possible outcomes are there. Therefore, each of them has a probability of 1 by 11. Is it correct? If you look at the table here, this is the probability table. Okay, they are not mutually exclusive events. First thing. Okay, and uh, they are not equally possible events. Okay, possibility of getting 7 is very high as compared to others. If you see here, correct? Possibility of getting a 7 is very high because this is 6 by 36. Remaining all is less. So definitely all these 11 possible outcomes is correct, but probability is not same for all of them. The probabilities are different. Okay, next. A game consists of tossing a 1 rupee coin 3 times and nothing and noting its outcome each time. Okay. Dikshita wins if all tosses give the same result. That is 3 heads or 3 tails, and loses otherwise. Calculate the probability. Okay. So this is simple. Total number of outcomes when the coin is tossed 3 times is 2 power 3, which is 8. Out of the 8, only 2 are the favorable outcomes. Okay. Possibilities of winning is only 2 out of 8. That is H, 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 or heads, 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 or tails, tails, tails. Okay. So possibility of winning is 1 by 4. Possibility of not winning is complementary. So 1 minus 1 by 4, which is 3 by 4. Next. Dice is thrown twice. What is the probability that 5 will not come up either time? Or 5 will come up at least once. Okay. Total outcomes when the dice is thrown is 36. Out of that, outcomes with 5 on either side are 11. Okay. These are the possible things, right? Okay. 11. So possibility of not getting any 5 is 25 by 36, and possibility of getting 5 at least once is 11 by 36. Okay. So try to make a set like this. Okay. Then it will be easy for you to answer any question. Okay. Next. Yeah, let's do this optional exercise also. Two customers, Shyam and Ekta, are visiting a particular shop in the same week, Tuesday to Saturday. Each is equally likely to visit the shop on any day as on another day. Okay, they are equally likely events. What is the probability that both will visit the shop on same day, consecutive day, different days? Okay, so just make a table. That's simple. List of all possibilities that Shyam and Ekta will visit shop. Okay. Both will visit Tuesday, Wednesday, Tuesday, Thursday, Tuesday, Friday, Tuesday, Saturday, then Wednesday, Thursday, Wednesday, Tuesday, Wednesday, 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 Thursday. So name all like this. Okay. So total possibilities now we know they are 25. Okay. And out of that, both visiting on the same day. T T W W. Okay. TH Thursday, Thursday, Friday, Friday, and Saturday, Saturday. That is 5. So 5 out of 25 is visiting on the probability of visiting the same day. Okay. Probability both visiting consecutive days. Okay. Tuesday, Wednesday. Okay. Then Wednesday, Tuesday. Okay. And Wednesday, Thursday, 3. So like that you count. So what you will get is a probability of visiting on consecutive days 8 by 25. 8 you will get. Okay. A probability of visiting on different days. Okay. Is basically if you know probability of visiting same day is 5. So 25 minus 5 by 25, which is 4 by 5. These two are complementary, right? So this is how you solve the problem. Next. A bag contains 5 red balls and some blue balls. Some blue balls. We don't know how many. If the probability of drawing a blue ball is double that of a red ball, what is the number of blue balls in that bag? So it's like definitely it is twice number of balls are there. Okay, but we can do it in a mathematical way this way. Let's assume that there are x number of blue balls. So total number of balls in the bag is 5 plus x. Probability of drawing a red ball is 5 by 5 plus x. Probability of drawing a blue ball is x by x plus x. Okay. So this is twice that of this red. Correct. So which means x is equal to 10. So there are 10 number of blue balls in the bag. Okay. Next. A box contains 12 balls, out of which x are black. If one ball is drawn at random from the box, what is the probability that it will be a black ball? Okay. This is the first question. Then we'll first go. Total number of balls are 12. Number of black balls are x. So x by 12 is the drawing a black ball. Okay. Now total number of balls after adding 6 balls. Okay. If 6 more balls are put in the box, the probability of drawing a black ball is now double that of it was before. Okay. So if 6 balls are added, total number of balls will be 18. So drawing a black ball now is x plus 6 by 18. Okay. This is double twice that of this one. Right. So x plus 6 by 18 is equal to 2 into x by 12. So just do a simple simplification. Then what you will get is 36x here, 36x equal to 12x plus 72. So if you simplify, x is equal to 3. Okay. So initial probability is 1 by 4. Okay. Next. A jar contains 24 marbles. Some are green, other are blue. Okay. If a marble is drawn at a random from the jar, the probability that it is green is 2 by 3. Okay. Find the number of blue marbles in the jar. Okay, this is simple. Let the number of total marbles are 24. Probability of drawing a green is 2 by 3. Let there be x number of green marbles. So x by 24 is equal to 2 by 3 or x is equal to 16. So number of blue balls are 24 minus 16, which is 8. Okay, these are the kind of problems what you see in the probability in 10th class level. Understand the basics very well. Each term, each word carefully should go into your mind, because probability is going to be very big in the 11th and 12th. Okay, and these are the easy scoring chapter probability. You will get a lot of problems in probability in all your competitive exams like JEE mains, JEE advanced, uh, whether it is any other MSET or any other competitive exam. You will get more problems in probability. You don't need to take a lot of time for this. This is a time saving problems. Understand the basics very well now, and keep solving more advanced problems. I will also do my videos for uh, advanced level probability questions. I will start doing those. Thank you. Until then, keep doing maths.